All right, here are the notes for section 7.5, comparing two variances or standard deviations. So notation, so S1 squared is the larger of the two sample variances, and one size of the sample with the larger variance. Sigma 1 squared variance of the population from which the sample with the larger variance is taken. So S2, N2, and sigma 2 are all from the smaller group. So S1 is the, so we're going to have to calculate both S's, but we can't set S1 or S2 until we know which one's bigger, because S1's always the larger of the two. So population is independent, simple random samples, normally distributed regardless of their sample sizes. So if one of the populations is not normally distributed, this test doesn't work very well. Okay, so our test statistic is this F value. So where S1 is the larger of the two, so F should always be more than 1, because the top of this fraction should be more than the bottom of the fraction. Weird notation here. Use the table to find the critical F values. Use to determine the following. The number 6 little a, numerator of degrees of freedom, and then N2 determines the row. So we have another table we're going to look in. For significance level alpha 0.5, use the right tail of 0.025 or half of that. Depend on the type of test as shown below. Two-tailed test, 0.25, one-tailed test, 0.5. Okay, so sample 1. So let's see here. So we actually did this kind of one before. So we have so S1 is the bigger of the two. So this has to be population 1, that has to be population 2, because this has the bigger S. So S1 is 0.97, X bar 1 is 3.39, N1 is 35, S2 0.63, X bar 2 0.397, N2 36. All right, so our F score is given by S1 squared over S2 squared. So that's going to be 0.97 squared over 0.63 squared. Actually, I guess it doesn't always have to be more than 1. 0.97 squared over 0.63 squared. So this comes out to be 2.37. Oh, sorry, we didn't do our hypotheses. Let me jot those down. So the hypothesis, so the null hypothesis is that the two variances are equal. H1, let's see here. Those with a red background have created sort of the standard deviation equal the blue background. So this is going to be so we're testing if they're equal. So this one's going to be not equal. So we have a two-tail. Okay. So let's see here. So we've got two tails. So we've got a failure region up here. We've got a failure region down here. Let's see here. So the number of degrees of freedom is 34 and 35. So then we look up the values. The critical value of F is between 1.8752 and 2.0739. Let's see here. No, whoops, sorry. No, that's not right. The table gives us. Okay, so let me see here. Up here, this value up here is 1.9678. If we look up the table, it's actually the actual value. 2.37 is more than that. So we reject H0. So it is likely that there is a difference between the two variances. So our value is more than our upper one here, so we get rejected. All right, and that brings us to the end of this section. Really short.